Africa is tearing apart, and the world is only just beginning to understand the scale of what is unfolding. In the remote deserts of East Africa, beneath blistering heat and endless salt plains, something extraordinary is happening. The ground is cracking open. Villages are shaking. Roads are splitting in half. And deep below the surface, a colossal force is rising, reshaping the entire continent from the inside out. This isn't a theory. This isn't a prediction. This is real, measurable, ongoing geological change. And we are the first generation in human history to witness a continent begin to split into two. Scientists on the ground in 2025 recorded massive fissures opening in the Afar region of Ethiopia, chasms so wide they swallowed entire roads and ripped through landscapes in a matter of hours. What they discovered shocked even the experts. The Earth's crust is actively stretching, thinning, and tearing apart under the pressure of a gigantic mantle plume, forcing its way upward from the depths of the planet. This plume, hotter than molten steel, pulses like a heartbeat beneath Africa, sending waves of energy that crack the land and trigger sudden bursts of seismic and volcanic activity. For decades, geologists suspected that Africa was slowly splitting. But now, with fresh satellite data, seismic maps, and real-time eruptions, the evidence is undeniable. Africa is on the path to becoming two separate continents, divided by what will eventually become a new ocean. An ocean that may reshape coastlines, shift climates, alter ecosystems, and redefine the map of our world. But this story is bigger than Africa. It's bigger than geology. It is a rare chance to watch Earth rewrite itself. The same process that once tore Europe from America to create the Atlantic Ocean is now happening beneath the feet of millions of people, and it's accelerating. In this video, we'll take you inside the Afar Triple Junction, one of the most extreme and volatile landscapes on Earth, where three tectonic plates pull apart at once. We'll explore the volcanoes, the earthquakes, the giant fissures, and the deep forces driving this planetary transformation. And we'll reveal what scientists believe will happen next, including how soon seawater could rush into the continent and form the world's next ocean. This is the birth of a new world, and you're about to witness it.
Africa is tearing apart, and for the first time in human history, we are witnessing the early stages of a continental split unfold not in textbooks or geological models, but directly on the surface of the Earth. In 2025, scientists stationed in Ethiopia's Afar region recorded an extraordinary sequence of events. Cracks opening across the desert floor, fissures stretching for kilometers, and violent ground ruptures strong enough to swallow roads and fracture entire villages. This wasn't an earthquake in the traditional sense. It wasn't a landslide or a collapse caused by rain or erosion. This was the crust itself pulling apart under immense internal pressure, exposing the raw mechanics of a continent being slowly torn in two. For the people living in the area, the moment was terrifying. The land they had lived on for generations, land they believed firm and immovable, suddenly behaved like something alive, restless, and unpredictable. Houses shook as if gripped by invisible hands. Roads buckled and dropped into dark, jagged openings. Dust billowed across the plains as the earth split, and ancient fault lines came back to life in a matter of seconds. To scientists, however, what unfolded in Afar was a rare and scientifically priceless phenomenon. Normally, continental rifting occurs over millions of years, slowly and silently, far from human eyes. But in Afar, nature reveals its secrets openly, dramatically, and sometimes violently. The region sits atop one of the most unstable tectonic intersections on Earth, a place where the crust is thinning, weakening, and stretching to its limits. Instruments placed across the desert picked up a surge of micro-earthquakes leading up to the event, Faint tremors too subtle for humans to feel, but clear warnings that tension underground was nearing its breaking point. And then, with startling suddenness, the land ripped open. What makes this moment so extraordinary is not just its scale, but what it represents. The Afar Depression is essentially the front line of a geological battle between the forces that shape continents. The crust here is thinner than anywhere else in Africa, pulled like dough until it nearly snaps. And when the pressure builds to the right point, it gives way in spectacular fashion. Across the dry, scorching plains of Afar, fissures opened like open wounds on the surface of the planet. Some stretched for hundreds of meters, others extended for kilometers. People watched in disbelief as solid earth tore itself apart, responding to forces deep underground that no one could see but everyone could feel. Scientists rushed to the site to capture images, take measurements, and analyze the newly formed cracks. What they saw confirmed a truth they had long suspected. Africa is not simply shifting, it is actively breaking. And what we witnessed in 2025 was one of many steps toward the formation of an entirely new ocean. This region has cracked before, and it will crack again. The Afar Depression is the epicenter of a massive tectonic process driven by heat rising from the mantle and the movement of colossal tectonic plates slowly drifting apart. Each fissure, each tremor, each fracture in the ground is part of a much bigger story, one that will eventually split the African continent into two and reshape the geography of the world. For us, these events are dramatic natural disasters. For the Earth, they are simply part of a cycle billions of years old. And in Afar, we are witnessing that cycle not as silent history, but as living, unfolding reality beneath our feet.
The Afar region is a paradox, hostile, scorching, and unforgiving, yet one of the most important places in the story of humanity. Long before it became the stage for Africa's geological transformation, it was the cradle of our species. To stand in Afar is to stand where the earliest chapters of human evolution were written, in a landscape that has shaped us physically, culturally, and now scientifically in ways few places on Earth ever have. It is here that scientists have found fossils belonging to some of humanity's oldest ancestors. Among them is Ardipithecus ramidus, a species that walked the Earth millions of years ago, providing clues to how humans first evolved upright walking. Then there is Lucy, the iconic Australopithecus afarensis skeleton discovered in 1974. Lucy's fragile bones, uncovered in the dry soil of Afar, reveal details about early human locomotion, brain development, and behavior. To this day, she remains one of the most important fossils ever found, and her discovery transformed the world's understanding of human origins. Afar, in many ways, is the birthplace of humankind. Its landscape, once dotted with lakes and lush environments, supported generations of early hominins who adapted to its shifting climate and terrain. Those ancient environments have long since vanished, replaced by lava fields, salt flats, and cratered volcanic slopes. But beneath the scorching sun and the barren ground lies a history written in stone, a history of life, evolution, and transformation. Today, Afar is undergoing a different kind of change, one that mirrors the immense forces that shaped it millions of years ago. It is no longer just the birthplace of our ancestors, it is becoming the birthplace of a new continent. The same conditions that preserved fossils for millions of years are the result of tectonic forces that continue to shape the region today. As the African, Somali, and Arabian plates pull apart, the crust thins and cracks, valleys sink, volcanoes erupt, lakes form and vanish. The landscape is dynamic, shifting constantly in response to the forces deep beneath the surface. In this sense, the geological activity that will one day divide Africa is part of the same story that once made Afar habitable for early humans. The region's transformation from lush cradle of evolution to scorching tectonic battlefield is not a contradiction, it is a continuation.
What makes Afar so extraordinary is not just the violence of its geology or the significance of its fossils. It is the way both stories intertwine. The fossils embedded in the ground tell the tale of millions of years of evolution. The fissures opening across the desert tell the tale of millions of years of tectonic movement. Together, they create a place where the past and the future collide. Every step taken in Afar carries the weight of history and the echo of what is to come. The cracked earth beneath one's feet reminds visitors that the ground is alive, shifting and reshaping itself. The volcanic mountains on the horizon are monuments to the heat below, the same heat that drives the rift tearing Africa apart. And the ancient fossils preserved in the soil whisper stories of ancestors who once walked this land long before the first tectonic crack appeared. The Afar region is both a museum and a prophecy. It shows us where we come from and where the Earth is heading. Humanity was born here, and now, before our eyes, the next chapter of the planet's evolution is unfolding in the same place. The ground that once nurtured early humans is now being pulled apart by the deep forces of the Earth, setting the stage for one of the most dramatic geological events in the planet's future, the birth of a new ocean and the splitting of a continent.
Beneath the blistering heat and rugged surface of the Afar region lies one of the most important geological crossroads on Earth, a place scientists call a triple junction. It is here that three massive tectonic plates meet: the African plate, the Somali plate, and the Arabian plate. Unlike most places where two plates collide or separate, Afar is a rare zone where three plates are simultaneously pulling away from one another. This makes it one of the most unstable and geologically active regions on the planet, a place where the crust is literally being tugged in multiple directions at the same time. Imagine the Earth's crust as a giant puzzle made of rigid pieces floating atop a semi-fluid mantle. These pieces, the tectonic plates, are always in motion, slow, deliberate, and unstoppable. At the Afar triple junction, the puzzle is being pulled apart at three seams. The Arabian plate moves northeast toward Asia. The Somali plate shifts westward, and the Arabian plate drifts southeast. These movements may be slow, just a few centimeters each year, but over millions of years they are powerful enough to reshape entire continents. The result is a region under constant tension. The crust stretches like taffy, thinning in some places and cracking in others. Old fractures buried deep within the Earth suddenly reactivate, becoming pathways for molten rock. Volcanoes form, earthquakes rumble, valleys sink, and occasionally the land rips open in explosive bursts, like the massive fissure recorded in 2005. The forces at the triple junction are so intense that the surface of Afar is slowly dropping relative to the surrounding land. In some areas, the ground is sinking by several millimeters each year. Over time, this subsidence creates deep rift valleys, long, sunken corridors bordered by steep cliffs. These rifts are the scars of the Earth's crust being torn apart. In Afar, they stretch across hundreds of kilometers, marking the boundaries where the plates are drifting away from each other. But the triple junction is not just a surface feature. Its influence extends miles beneath the ground. The mantle beneath Afar is unusually hot. This heat softens the crust and makes it easier for the plates to move apart. Large plumes of molten rock rise from deep within the Earth, pushing upward with immense pressure. As they do, they weaken the crust even further, creating zones where the land is prone to cracking. When the plates pull apart faster than the crust can stretch, the surface fractures suddenly. These fractures become the fissures in giant cracks we see today.
The meeting of three plates also creates a kind of geological tug-of-war. Each plate influences the movement of the others. If one plate shifts slightly, the stress redistributes instantly, sometimes triggering earthquakes or volcanic eruptions miles away. This interconnectedness is what makes the Afar region so unpredictable and so scientifically valuable. No other place on Earth provides such a clear view of how continents break apart. The triple junction is the engine driving Africa's split. Without it, the rift would not exist, the volcanoes would not erupt, and the dramatic fissures that now scar the landscape would never have formed. It is the starting point of a process that will eventually divide the African continent into two distinct landmasses. When we look at the Afar triple junction, we are looking at the blueprint of Earth's future geography. This is the tear in the fabric of the continent, the precise location where Africa's breakup began and where it continues today. 1 millimeter, one eruption, and one crack at a time.
To understand how a continent like Africa can split apart, we must look beneath the surface, far below the rocks, valleys, and volcanoes of the Afar region, to the deep engine that drives the movement of continents, plate tectonics. The ground beneath our feet may feel solid and unmoving, but in reality, Earth's crust is divided into enormous slabs called tectonic plates. These plates float atop a softer, partially molten layer of the mantle, known as the asthenosphere. They drift slowly, at roughly the same speed your fingernails grow, just a few centimeters per year. It sounds insignificant, but over millions of years, these tiny movements reshape the entire face of the planet. Africa's split begins with a process known as rifting, when tectonic plates pull apart. In the Afar region, the Somali plate is moving away from the African plate, while both are also separating from the Arabian plate. This creates a zone of extreme tension. When plates try to move apart, the crust between them doesn't simply glide open. Instead, it stretches. But rock is strong only to a point. When it can no longer withstand the tension, it begins to thin, crack, and eventually tear. Imagine a piece of dough being stretched. At first it thins evenly, but keep pulling and it starts to tear along the weakest spots. Earth's crust behaves the same way, but instead of dough, it's solid rock, and instead of a few seconds, the stretching occurs over millions of years. The cracking happens in several stages. First come tiny fractures that are barely noticeable. These grow into larger fissures and faults, long cracks where sections of crust move relative to each other. As the crust continues to stretch, the land between these faults begins to sink, forming deep valleys known as rift valleys. These valleys fill with volcanic rock, sediment, or water, depending on the landscape. Over time, some valleys collapse further, forming massive chasms like the East African Rift, a scar stretching thousands of kilometers across the continent. But stretching alone doesn't fully explain Africa's dramatic transformation. Something deeper is happening. Rising heat from the mantle plays a critical role in tearing the continent apart. Beneath the Afar region lies a plume of warm, buoyant mantle material pushing upward. This heat thins the crust from below, weakens it, and makes it easier for tectonic forces to rip it apart. As the crust thins and breaks, magma from the mantle rises through the cracks. Sometimes it erupts as lava, building volcanoes or spilling across the land. Other times it remains underground, forming dikes, vertical sheets of molten rock that push the crust aside like a wedge. The more magma forces its way upward, the wider the rift becomes. This combination of stretching from above and heating from below is what creates the extraordinary geological behavior we see in East Africa. Rifting is slow, relentless, and unstoppable. Some areas experience dramatic events like the 2005 fissure, where the crust tore open in days. Other areas stretch silently, only detectable by sensitive satellites.
But the outcome is the same. The crust becomes thinner and weaker until it breaks. Over millions of years, as the rift widens, the land will drop low enough for seawater to flood in. What begins as a long valley will transform into a narrow sea, then a wider gulf, and eventually a full-fledged ocean. This is the process that once separated South America from Africa and created the Atlantic Ocean. The Earth is repeating that cycle in East Africa right now. When we look at the Afar region, we are watching the birth of a new ocean, driven by forces older than the continents themselves. A slow-motion tectonic ballet that will reshape the world long after humanity is gone.
In the history of Africa's breakup, few events have captured the world's attention like the massive fissure that struck the Afar region in 2005. It was the moment when the quiet, steady process of continental rifting suddenly became loud, violent, and impossible to ignore. What normally happens over centuries unfolded in just days, giving scientists a rare front-row seat to one of Earth's most dramatic geological processes, the crust cracking open in real time. It began with a swarm of earthquakes. Seismometers rattled with activity as hundreds of small quakes rippled through the region, each one a sign that the crust was under immense tension. Locals felt the ground trembling under their feet. The air vibrated. Distant booms echoed across the desert as if something deep underground was shifting, preparing to rise. Then came a deeper, more powerful rumble, a warning that something extraordinary was about to happen. Within hours, the earth split open. A colossal crack tore across the desert floor, stretching nearly 37 miles or 60 kilometers long. In some places, the ground yawned open by as much as 8 meters. Imagine driving down a familiar road one day, only to find the next morning that it has vanished into a jagged canyon. Entire stretches of land dropped or shifted sideways. The crust didn't crumble, it separated. But the spectacle on the surface was only the beginning of the story. The real drama was happening underground. As scientists rushed to the scene, they discovered that the crack was the surface expression of something much larger, a massive dike intrusion. A dike is a vertical blade of magma that forces its way upward through the crust, pushing rock aside like a glowing underground wedge. In 2005, such a dike, up to 2 meters thick, shot up from the mantle and injected itself between the plates, spreading across the region in a matter of days. This wasn't lava gently bubbling out of a volcano. This was magma acting like a geological crowbar, prying the African continent apart. Using satellites and GPS measurements, scientists watched the land move in near real time. Entire blocks of crust shifted outward as the dike expanded. The ground stretched and cracked like a wound tearing open wider with each pulse of molten rock. Fresh lava seeped into the fissure, creating a scar of black volcanic stone across the desert. The Afar Depression became a natural laboratory. Researchers mapped the crack's length, measured its width, collected samples, and studied the seismic waves that followed. For the first time in modern history, they could observe a full rifting episode from start to finish. They confirmed what had long been suspected. Africa is not splitting slowly and evenly, but in sudden, powerful bursts triggered by magma rising from below. For the people living nearby, the experience was frightening and surreal. Roads were destroyed, water lines snapped, livestock disappeared into the cracks. Villages found themselves standing on unstable ground that shifted unpredictably. It was a stark reminder that the continent they call home is part of a much larger planetary process, one that does not pause for human settlement or convenience. But for scientists, 2005 was a revelation. It demonstrated that the forces tearing Africa apart are not theoretical, they are active, ongoing, and accelerating. It proved that tectonic plates can shift dramatically in a matter of days when driven by rising magma. And it showed that what we see on the surface is only a small glimpse of the enormous geological machinery operating below.
The 2005 fissure was not a one-time event. It was a preview of things to come. A reminder that the cracks opening today are the first steps toward a distant future where Africa will be split into two continents, divided by a new ocean born from fire, pressure, and the unstoppable movement of the Earth's crust. To understand why the African continent is tearing apart so violently, we must travel deep beneath the surface, far deeper than any fissure, volcano, or earthquake can reveal. There, in the hidden layers of the Earth, lies a colossal force driving the entire rift system, a mantle plume, a rising column of hot, buoyant rock slowly pushing upward from thousands of kilometers below. This plume is the engine powering the breakup of Africa, a geological heartbeat pulsing under the Afar region. The concept may sound abstract, but its effects are anything but. A mantle plume acts like a blowtorch pressed against the base of the crust. As the plume rises, it spreads out, heating and weakening the overlying rock. In Afar, where the crust is already thin due to tectonic stretching, the plume's heat melts and softens the lithosphere even further, making it easier for the continent to split. This is why Afar is unlike any other place in Africa. Other regions sit on thick, stable crust, but Afar sits at the top of a restless, simmering reservoir of magma, whose pressure ebbs and flows like a living system. One of the most fascinating discoveries about this plume is that it does not rise smoothly or consistently. Instead, it pulses. Seismic tomography, an imaging technique that lets scientists peer deep into the Earth, shows zones where seismic waves slow dramatically, indicating hotter, more fluid rock. These anomalies pulse upward periodically, like surges of molten energy rising from the deep mantle. Each pulse increases the pressure beneath Afar, pushing magma upward, causing the crust to bulge, quake, and crack. Some pulses are subtle, producing only tiny shifts detectable by satellite. Others are dramatic, triggering events like the 2005 fissure, where a massive dike of magma was injected into the crust in days. The plume's influence extends far beyond the Afar region. Volcanoes across Ethiopia and Eritrea bear its chemical signature. Lava samples collected from eruptions contain isotopes that trace back to astonishing depths, perhaps even near the core mantle boundary, one of Earth's most remote and mysterious regions. This suggests that the Afar plume may be tapping into some of the deepest and oldest reservoirs of mantle material on the planet. Satellite measurements further reveal the land rising and falling in rhythm with the plume's pulses. GPS stations anchored into bedrock detect the continent drifting apart by millimeters each year. Some areas subtly inflate as magma accumulates. Others deflate after eruptions or dike intrusions. From orbit, it appears as though the ground itself is breathing. On the surface, the plume expresses itself through a chain of volcanoes. Erta Ale, with its persistent lava lake, is one. Dabahu, which erupted during the 2005 rifting episode, is another. These volcanoes are like pressure valves in a giant system, releasing heat and magma to the surface. When pressure builds too high, new fissures open. When magma finds a weak point, it erupts violently. The plume doesn't just cause eruptions, it shapes the entire region. It weakens the crust, allowing the tectonic plates to continue pulling apart. It injects magma that forces the ground to shift. It fuels earthquakes that crack the land. It is the underlying source of the geological chaos unfolding in Afar. What's remarkable is how much scientists have learned by combining seismic imaging, lava chemistry, and satellite data. Those three lines of evidence all point to the same conclusion. The Afar plume is not a passive feature. It is an active, dynamic force reshaping the continent from below. Without the plume, the African rift would be slower, quieter, and far less dramatic. But with it, the continent is splitting at an accelerated pace, punctuated by volcanic eruptions, earthquakes, and sudden ground ruptures.
In many ways, the plume is writing Africa's future, one pulse, one crack, and one eruption at a time. And as it continues to push upward, the continent above continues to weaken, setting the stage for the formation of a brand new ocean.
On the surface, the Afar region looks like a brutal desert, dry, cracked, and seemingly lifeless. But to a geologist, this landscape is a living diary filled with visible evidence of the deep forces tearing Africa apart. Every ridge, volcano, fissure, and tremor is a clue left behind by the mantle plume and the shifting tectonic plates below. And when you know how to read these clues, the story becomes impossible to ignore. The crust in East Africa is actively breaking, sinking, and reshaping itself in real time. One of the most striking features of Afar is its volcanoes. Dotting the desert like fire-born mountains, each one is a mark of the intense heat rising from the mantle. Some of these volcanoes, like Erta Ale, are famously active, with lava lakes glowing red-hot for decades. Their constant activity shows that molten rock sits just beneath the surface, pressuring the crust like steam inside a kettle. Other volcanoes in the region lie dormant but are draped in fresh black lava flows that cooled only decades or centuries ago, a blink of an eye in geological time. These volcanoes are not isolated phenomena. They form a chain that traces the boundaries where the tectonic plates are pulling apart. Together, they are the surface expression of an enormous plumbing system that channels magma upward from the deep mantle. Then there are the fissures, jagged cracks stretching for kilometers, slicing across roads, fields, and villages. Some of these fissures formed during dramatic events like the 2005 dike intrusion. Others appear gradually, widening year after year as the crust continues to stretch. Step into one of these fissures, and you are standing inside the scars of a continent in transition. The ground around them often tilts or collapses as the land adjusts to the strain. For people who live here, these cracks are disruptions. For scientists, they are windows into the mechanics of continental breakup. The rocks themselves hold critical information as well. Geologists collect samples of cooled lava, volcanic ash, and pumice. When analyzed, these rocks reveal the temperatures, pressures, and chemical compositions of the magma that formed them. Some minerals contain isotopes that pinpoint the magma's origin in the deep mantle, confirming the presence of the powerful plume below. Others contain trapped bubbles of ancient gases, preserving traces of Earth's interior conditions. Studying these samples is like reading a diary written by the planet itself. Earthquakes provide another vital clue. Although many are too small for people to notice, seismometers across Afar detect hundreds of tiny tremors every year. Each one marks a moment when the crust cracks, shifts, or adjusts to the stress placed upon it. Patterns in the seismic waves reveal where the crust is thinnest, where magma is accumulating, and where new fissures are likely to form. Occasionally, a larger earthquake rattles the region, signaling that the rift has taken another step towards splitting wider. And the land itself is changing shape. Using satellite-based GPS stations anchored deep into bedrock, scientists can track movements of less than a millimeter. These instruments show the land drifting apart slowly but consistently. Some regions rise slightly as magma pushes upward, others sink as the crust stretches and thins. From space, satellite images reveal the Afar depression sagging downward over time, like dough being pulled apart from beneath. Even the colors of the landscape reveal this geologic activity. Bands of black basalt mark sites of recent lava flows. White salt flats indicate regions where water once pooled but has since evaporated due to rising heat and sinking land. Yellow sulfur fields signal volcanic gases seeping through cracks. All of these surface changes align perfectly with what seismic scans and GPS data show beneath the ground. The African continent is cracking open, piece by piece. Taken together, these clues paint an unmistakable picture. Volcanoes show where magma reaches the surface. Rocks record the chemistry of Earth's deep interior. Earthquakes reveal the tension ripping the crust apart. And satellite measurements track the slow, relentless widening of the rift. Africa is not just shifting, it is transforming. The surface of the continent bears the fingerprints of this transformation everywhere, visible to anyone who knows how to look. As dramatic as the cracks, volcanoes, and earthquakes of the Afar region appear today, they are only the opening act of a far more profound transformation, one that will permanently reshape the map of Africa and the world. The land is not merely breaking, it is preparing for something astonishing, the birth of a new ocean. To understand this future, we need to look at how continents have behaved throughout Earth's history. The Atlantic Ocean, for example, began as a small rift valley millions of years ago, when South America and Africa started drifting apart. What started as a crack in the crust eventually widened, sank, flooded, and grew into the vast ocean we know today. The same process is unfolding right now beneath East Africa. The rift system, stretching from the Red Sea down through Ethiopia, Kenya, Tanzania, and beyond, is slowly splitting the continent into two massive land masses. On one side will be most of present-day Africa. On the other will be a new plate made up of Ethiopia, Somalia, Eritrea, Djibouti, and parts of Kenya and the Horn of Africa. The boundary between these two future continents will one day be filled with ocean water. How? As the rift widens, the land will sink. The Afar Depression, already one of the lowest points in Africa, is sinking faster than almost any other place on Earth. Satellite data shows continuous downward movement as the crust stretches and thins. Eventually, this depression will drop below sea level. When that happens, the Red Sea or the Gulf of Aden will rush inland like a massive, unstoppable flood. Water will surge into the valley, filling it over thousands of years until a long, narrow sea forms, similar to how the Red Sea itself began. Over millions of years, tectonic forces will continue pulling the land apart, widening the sea into a true ocean basin. The future coastline of Africa will look dramatically different. Cities that are now hundreds of kilometers from the ocean may one day sit on new shores. Mountain ranges will rise on the edges of the new ocean, created by the shifting crust. Islands may form along volcanic ridges. Entire ecosystems will emerge where today there is only desert. But the timeline of this transformation is one of the most challenging aspects to predict. Some scientists believe the rift could flood within tens of thousands of years. Others estimate hundreds of thousands. To the Earth, these spans of time are insignificant, a blink of an eye. To humans, they feel unimaginably distant. Yet, the Earth has shown us that sometimes the process accelerates. The 2005 dike intrusion proved that the crust can shift dramatically in days, not centuries. If enough of these sudden events occur, the rift could deepen and widen faster than expected. Future generations might witness the early stages of the ocean's birth. The new ocean will not just reshape geography, it will reshape society. Trade routes will shift, nations will adapt to new coastlines, marine life will colonize the newborn waters. The climate may even be influenced by the creation of a new ocean basin, changing wind patterns and moisture distribution across East Africa. It is a profound reminder that Earth is not a static world. Continents are not fixed. Coastlines are temporary. Everything about the surface of our planet is in motion, shaped by forces deep below that never sleep. When future maps are drawn, Africa will not look like it does today. The Horn of Africa will be separated from the mainland. A young ocean will lie between the two new continents. And the Afar region, the scorching desert where humanity began, will become the birthplace of a new sea. The Earth has done this before. and it will do it again. The story of Africa's split is not an ending. It is the beginning of the next chapter in the planet's long and restless evolution.
Africa's slow but unstoppable split is not just a regional story, it is a global one. The forces tearing the continent apart ripple outward in ways that affect ecosystems, populations, economies, and even the climate far beyond East Africa. To understand why this matters, we must look beyond the cracks in the ground and recognize that continental rifting is part of a much larger planetary cycle. A cycle that has shaped Earth for billions of years and continues to influence life today. The most immediate impact of Africa's split is geological. As the plates pull apart, earthquakes become more frequent and sometimes destructive. Although many tremors are too small to be felt, the cumulative effect is significant. Larger quakes can damage infrastructure, threaten communities, and destabilize regions already vulnerable to natural hazards. In a place where millions of people depend on farming and pastoralism, even a minor shift in the ground can disrupt water sources, crack irrigation systems, or destroy roads essential for delivering food and supplies. Then there are the volcanoes. East Africa is dotted with active and dormant volcanoes, many of which owe their existence to the same rifting forces splitting the continent. When these volcanoes erupt, they can send ash plumes thousands of meters into the air, disrupting aviation routes across continents. A single large eruption could inject enough sulfur dioxide into the atmosphere to temporarily cool the planet, altering weather patterns. Such events have happened before, and they will happen again, especially in an area where molten rock is constantly rising toward the surface. But these dangers are only part of the picture. Rifting also brings opportunities. One of the most promising is geothermal energy. Because the crust in East Africa is so thin and hot, geothermal power plants can tap into Earth's internal heat to generate electricity. Countries like Kenya, Ethiopia, and Djibouti are already investing in geothermal technologies, using the rift's natural heat as a clean, renewable alternative to fossil fuels. As the rift expands, these opportunities will grow, potentially transforming the region into a hub of sustainable energy production. Africa's split is also connected to a wider pattern of geological evolution across the globe. Similar rifting processes are happening in Iceland, where the mid-Atlantic ridge breaks the island in two. Visitors can walk along paths that pass directly between the North American and Eurasian plates. Iceland's dramatic volcanic eruptions, hot springs, and geysers all stem from the same kind of mantle plume-driven tectonic activity that shapes East Africa. In the western United States, the Basin and Range province is slowly stretching, creating long valleys and mountain ranges. The Gulf of California is also widening as the Pacific Plate pulls away from the North American Plate. Some scientists believe that over millions of years, seawater could eventually extend northward into the American Southwest, creating a new coastline. These examples show that Africa's split is not an isolated phenomenon. It is one chapter in Earth's long story of assembling and breaking apart continents. All landmasses, no matter how stable they appear, are temporary arrangements in a constantly shifting system. Rifts become seas, seas become oceans. Oceans close as continents collide again. This cycle has repeated itself for billions of years. Today, East Africa is one of the few places where we can watch this cycle unfold in real time. It is a living classroom where the planet reveals its inner workings. And perhaps most importantly, it reminds us that the maps we grow up with are not permanent. Coastlines we know today may vanish or shift. Regions that are landlocked may someday sit beside a new ocean. Human civilizations will adapt, just as ecosystems have done through countless geological cycles. In Afar and across East Africa, people continue their daily lives on ground that is slowly drifting apart. They farm, herd livestock, build homes, and raise children, often unaware that the land beneath their feet is part of a planetary transformation. The Earth moves on a timeline far longer than ours, and while we may never see the final split or the first waves of the new ocean, we are here to witness the beginning. Africa's rift is a reminder that our planet is alive, restless, and forever changing. And in this moment of deep time, humanity has a front row seat to one of Earth's greatest transformations. Africa is splitting. A new ocean is forming, and we are witnessing a transformation that only happens once in hundreds of millions of years. Today, you've seen the fissures, the volcanoes, the shifting valleys, and the deep forces reshaping our planet from within. But remember, this story is still unfolding. Every day, East Africa moves a little more, carrying the continent toward a future no human has ever witnessed. As one chapter of Earth closes, another begins. The birth of an ocean, the creation of two Africas, and the rewriting of the world's map. If this journey amazed you, make sure to like this video, drop your thoughts in the comments, and share it with someone who loves science and discovery. And don't forget to subscribe. Your support helps us bring more incredible stories of our planet to life. Now, click the next video on your screen and continue the adventure.